So as we continue on with trig substitution, I would like to do a few trig formulas that we're going to need. Okay, so we've already talked about the basic ones. That is, the first one we talked about cosine squared of x, or u, plus sine squared of x is equal to 1. Tangent squared plus 1 is secant squared x. Cotangent squared x plus 1 is cosecant squared x. We talked about writing cosine squared of x as 1/2 times 1 plus the cosine of 2x, and the sine squared of x as 1/2 times 1 minus the cosine of 2x. And another one that we will need is the sine of 2x is equal to 2 times the sine of x times the cosine of x. And I don't think we really need the cosine squared. I mean, the cosine of 2x. I mean, I don't think we actually use this one in any of these, but this is the cosine squared of x minus the sine squared of x. Now, for our trig integrals, you will probably, so for the trigonometric integrals, we may need any one of the first few, but definitely for the trig subintegrals, you're going to need this one. Okay, so this one comes up in the trigonometric substitution integrals. Okay, any questions on anything that we're doing right now? Okay. You guys will like the next section better. Okay, so we were working on a trigonometric substitution problem. As you can see, we were solving 1 over 4 plus x squared squared, because we saw 4 plus x squared and it looked like a squared plus x squared. We were able to identify a squared is 4, a is 2. We also said that a squared plus x squared looked like a tan inverse. So therefore theta equals the tan inverse of x over a. And then that means that for x, a is 2, so x over 2 is tan theta. Then we came over here to our little triangle. And when we drew our triangle, we said if this is theta, then its tangent is x over 2. So that's the opposite over the adjacent. And then that means that the hypotenuse has to be the square root of 4 plus x squared. Okay, so there's some things that we need to find from this triangle. As you can see, we need to find dx. So dx needs to be figured out. And we also need to figure out what is going to be our 4 plus x squared. Okay, so once we find those things, then we can substitute and we can compute our integral. All right, so the first thing we have is that x over 2 is tangent of theta. So therefore x is 2 times the tangent of theta. Okay. The other thing I said to you, remember, functions have partners. So tangent's partner is what trig function? Tangent's partner is what trig function?
Secant.
Secant. Okay. So let's try to find the secant in this particular formula. So if I look at the secant of theta, well, that's going to be 1 over the cosine. So the cosine is the adjacent over the hypotenuse. So the secant is going to be the hypotenuse over the adjacent. So the secant of theta is going to be the square root of 4 plus x squared over 2. All right, that's nice. That's helpful, because now I know that the square root of 4 plus x squared is 2 times the secant of theta. So now I know what that is. And then dx, well, that's easy. Dx just turns out to be 2 times the secant squared of theta, d theta. So now I just need to do a substitution. So I have the integral of 1 over 4 plus x squared squared. Okay, so dx I got. Dx works. Here's dx, here's dx. But now I need to figure out what 4 plus x squared squared is. Well, this term right here is 4 plus x squared to the 1/2 power is 2 times the secant of theta. So therefore 4 plus x squared is basically raising that to the 4th power. So that's 2 times the secant of theta to the 4th power. So this becomes 16 secant to the 4th of theta. So now I know what that is. So now I can substitute. So my integral is the integral dx is 2 secant squared theta d theta and in the denominator I'm going to get 16 times secant to the 4th of theta. So this now becomes 1 over 8, the integral of 1 over secant squared theta. But that's actually kind of cool, guys, because secant is 1 over cosine. So this integral now becomes 1 over 8, the integral of the cosine squared of theta, d theta. How do I integrate that? How do I integrate that? This is the first thing we did.
Well, I want to say that it involves using the one of those trig equations you had brought up recently. So cosine squared equals half 1 plus cosine 2x, something along the lines of that.
That's exactly right. Okay, so I now get this is equal to 1 over 8, and cosine squared is 1/2 times 1 plus the cosine of 2 theta d theta. So now I get 1/16. And when I integrate, I get theta plus 1/2 the sine of 2 theta plus a constant. Okay, so that's what I get as an integral. Now, this is why I introduced that one trig function a few minutes ago, is because we need the fact that the sine of 2 theta is 2 times the sine of theta times the cosine of theta. So we're going to use that the sine of 2 theta is 2 times the sine of theta times the cosine of theta. So this now becomes 1/16 theta plus, when I put in that there, I just get the sine of theta times the cosine of theta, because the 2 and the 1/2 divide to be 1. Okay, so now I'm done with the section of the fact that my original problem was in X, and now my answer is in theta. I'm done. I've integrated everything. I've completed everything. I now need to go back to X. So now I'm going to scroll up and look to see what I need. I need theta, I need the sine of theta, and I need the cosine of theta. So let's scroll back up. Well, great. Theta is the tan inverse of X over A. So theta will be the tan inverse of X over 2. So we're going to have theta is going to be the tan inverse of X over 2. I need the sine of theta. So the sine of theta is the opposite over the hypotenuse. So that's going to be X over the square root of 4 plus X squared. So the sine of theta is going to be X over the square root of 4 plus X squared. And the cosine of theta, scroll back up, that's going to be 2 over the square root of 4 plus X squared. Okay. So now my answer, which I'm done, is 1/16. Theta is the tan inverse of X over 2 plus, and when I multiply the sine times the cosine, I get 2X divided by the square root of 4 plus X squared plus a constant. Okay. Any questions about that? So I'm going to go back for just a brief moment. We started off by knowing that we were doing integrals that had a squared minus x squared, a plus x, a squared plus x squared, or x squared minus a. And we remember, because you gotta, the difference between this class and other classes is a difference between remembering and recognizing. So while you guys were we were out for the pandemic and nobody was in school, most of what you were doing was recognizing. You had to look at something, recognize a formula, plug it in, and you could do that. Well, now we're back to how college normally is, which is where you don't have all that stuff sitting next to you. So you now have to recall and you have to remember. So I'm hoping that you have now remembered your formulas for the sine inverse, your tan inverse, and your secant inverse. So that helps correlate you to your trig substitution problems. So we've already done 2. So of course, now I'm going to do a secant inverse. And then we'll see what else we do. So here's number 3. I want to compute the integral of the square root of x squared minus 25 over x. And as I look at this, I see I have x squared minus a squared. And x squared minus a squared tells me I'm going to use theta is the secant inverse of x over a. So I now need to identify what's a. So a squared is 25. So a is 5. I now know that theta is the secant inverse of x over 5. So that says x over 5 is the secant of theta. But that just says that x is 5 times secant theta. Okay, so now I know x. So that's great because that'll fit right in here. I know what x is, so that's going to fit right in there. I now also need to know what the square root of x squared minus 25 is, and I also need to know dx. So you have a question, Ezekiel?
Yeah, I thought the inverse secant was absolute value of x.
It is absolute value, but when we're doing these problems, we assume everything is positive because we're in a triangle.
Okay, thank you.
So yeah, but you're right. When you actually compute an integral and you don't know that you're on a triangle, you have to use absolute value. But for these problems, we're assuming that everything is positive, that we're able to draw it inside of a triangle.
Can you scroll it up a little bit, please? Just a little bit.
Okay.
Right there.
Right here.
Yes, thank you.
Okay. Okay. All right, so here's my triangle. And I know that x over 5 is the secant. So that means x, this side must be x, and this side must be 5. That makes it the secant. But that then means that this side over here is x squared minus 25. Okay, so I have my triangle. All right. So now I say to you what I said before. If we're using secant, what's its partner? Its partner is tangent. So let's find the tangent of theta. So the tangent of theta is the square root of x squared minus 25 over 5. So now I can solve and get that the square root of x squared minus 25 is 5 times the tangent of theta. So now I know that. So I know this. That's 5 times the tangent of theta. I know x. Where's x? Here's x. X is 5 secant theta. So now I don't know dx. Okay, so let's find dx. So if x is equal to 5 secant theta, what is dx? What is dx? Whoa, crickets.
Secant x, tangent x.
Secant x, tangent x. Don't forget your 5. So it's secant theta, tangent theta, d theta. So now I get that the integral of the square root of x squared minus 25 over x dx. In the place of the x squared minus 25 square root, I'm going to put 5 times the tangent of theta. In the place of dx, I'm putting 5 times secant theta, tangent theta, d theta. And in the place of x, I'm putting 5 secant theta. So now this beautifully, the secants drop out, and so does one of the 5s. So this becomes 5 times the integral of the tangent squared theta d theta. Now, how do you integrate tangent squared? How do you integrate tangent squared?
Does it become secant squared minus 1?
Good. 5 times the integral of secant squared of theta minus 1 d theta. Now this is easy. The integral of secant squared is tangent. And the integral of 1 is theta. Okay, so I'm done. I got my plus C on the paper. So now I need to go back to my problem and find 2 things, theta and tangent theta. So when I scroll up, tangent theta is the square root of x squared minus 25 over 5. And theta is the secant inverse of x over 5. So in the place of tangent theta, I put the square root of x squared minus 25 over 5. And then I put the secant inverse of x over 5 plus a constant. So there's my answer. My answer turns out to be 5 times the square root of x squared minus 25. No, it doesn't. The 5's cancel. I get minus minus 5 times the secant inverse of x over 5 plus a constant. Okay. Give you guys one to work on while I take attendance. The integral of x squared over, did I do this one? Let me make sure I didn't do this one. I did x cubed. I did x cubed. Let me put it in the denominator. I'm gonna put the x squared in the denominator. I'm just gonna make that dx. Dx. And in the denominator, get this thing right. X squared times, what do I want? 16 minus 9x squared. Oh, that's a nasty one. Y'all can figure it out. I give you a hint. Switch to U first. So I would switch this to a U problem. So I would let a squared be 16 and U squared be 9x squared. So therefore U is 3x. Okay, so now you can work on that. And I am going to pause. Okay, who wants to start trying to talk our way through this problem? Well, let me ask this. Who switched it out to use already? Who switched it out to use and did that already? Oh, okay. Hello. Anybody get the U problem yet? Okay. For the U problem.
Wait, Professor, I have a question.
Yes.
So are we solving for like the a squared is equal to 16, the u squared is equal to 9x squared, right?
Right. So if we switch over to U's, because I've been showing you how to solve these problems when you had a squared minus x squared, not a squared minus 9x squared, right? So the a squared minus 9x squared is a little different. So we're going to switch out to a U problem. So in the place of 9x squared, we're going to put U squared. All right, so what do we know? We know that U is 3x. So what is du? What is du?
It's 3
Dx.
3dx. Yeah.
Okay, so therefore now I can solve for dx. So dx is 1/3 du. Okay, everybody with me? I haven't done anything yet. Okay. I need, so far, everything I can swap out. So far I can swap out the dx. The dx just becomes 1/3 du. Then in the denominator, the 16 is just the a squared. And the 9x squared is just u squared. And now I still need to get rid of x squared. So I need to solve for x. So x is u/3. So therefore x squared is u squared over 9. So now down here, I'm going to put u squared over 9. So now this integral becomes 3 du over the square root. I'm going to have u squared here, and I'm going to have a squared minus u squared. Okay, so now it's a u problem, but I'm not upset that it's a u problem because I know what to do with u. If I see a squared minus u squared, what does that tell me to do?
So then we have to do a subtract a squared from u squared, correct?
Say that again.
So we have to subtract a squared from u squared, correct?
Well, that's what's in the bottom.
Mm-hmm.
But now if I have a squared minus x squared, what do I use? I use theta is equal to the sine inverse. So when I have a squared minus x squared, I use theta is equal to the sine inverse of x over a. Well, I have a squared minus u squared. So theta is going to be the sine inverse of u over a. Just use a different variable. So that says u over a is equal to the sine of theta, or u is equal to a sine theta. Good, we're good, we're good. I need u squared. There it is. Here's u squared. So u squared is a squared sine squared theta. I need du. So du is a cosine theta. D theta. So now I got all that taken care of. What I need next is, what is the square root of a squared minus u squared? Well, to do that, I need a triangle. So here's my triangle. So let's use what we know. U over A is the sine of theta. So this side has to be the square root of A squared minus U squared. Okay, so now I have all of that. So now I have to figure out what the square root of A squared minus U squared is. In order to do that, I'm going to use sine's partner function. Its partner function is cosine. So let's find what the cosine of theta is. The cosine of theta is the square root of A squared minus U squared over A. So that just says that I now know what the square root of A squared minus U squared is. It is A times the cosine of theta. So now I know that. So everything I need is there on the paper. Okay. If you don't know what I did, say something and I can go back and explain it again.
Dr. Locke,
Yes.
the three that was separated as independent value is what was that from 1/3 divided by 1/9?
Yes, it is.
Okay, thank you.
Okay. So now my integral is 3. The integral du, put in du, there it is. A cosine theta d theta. Put in u squared. It is A squared sine squared theta. Put in the square root of A squared minus U squared. It is A cosine theta. So everything's in. D theta, du was A cosine theta d theta. U squared is A squared sine squared of theta. And then square root of A squared minus U squared is A cosine theta. So these divide out. So this integral becomes 3 over A squared. The integral of 1 over sine squared. Well, 1 over sine is cosecant. So this is just cosecant squared of theta d theta. Oh my gosh, that's so beautiful. Because cosecant squared is a perfect derivative. What does it integrate to?
Negative cotangent.
Thank you. Okay. So now I just need to switch everything back. So -3, a squared, well, we said a squared was 16. Cotangent of theta. So the tangent of theta would be u over the square root. So the cotangent is going to be the square root over u. So the cotangent is going to be the square root of a squared minus u squared. Over u. Okay, so that's the cotangent. Just by looking at this, the cotangent is this side over that side. Okay. Oh, I need to make a substitution. 3/16. A squared is 16. U squared, well, I gotta go back. I gotta go back to the original u. U squared was 9x squared. And u was 3x. Okay, so my answer is the square root of 16 minus 9x squared over 16x plus a constant, and it is negative. So what did we do in this problem? We started with x, we went to u, we went to theta, got an answer. So we started from theta, we went back to u, we went back to x, and we're done.
So do you want us just to leave like that?
That's the answer.
Okay.
Okay. One more. All right, where do I start? where do I start? Am I the only one on this call?
Would you use, will you represent u as 1 plus 4x squared?
Okay, so u squared. 4x squared. Okay, that's a good start. What else can I get? What's a squared?
1.
So what's u?
U would be sorry, probably 2. Would it be 2 or
2x.
x? Okay,
And what is a?
it would be just 1.
Okay. All right, so now I need dx. Because this is now going to be the integral of the square root of a squared plus u squared. And so dx has to go. So what is dx?
du over 2.
Okay, good. Du is equal to 2 dx. So dx is du over 2. Okay, so now I have a nice problem. 1/2 the integral of the square root of a squared minus u, a squared plus u squared du. Now let's go back. The integral of du over square root of a squared minus u squared. That's the sine inverse of u over a plus a constant. So I'm not going to use sine inverse. The integral of du over a squared plus u squared is 1 over a, the tan inverse of u over a plus a constant. Ah, that looks good. I see a squared plus u squared. So I'm going to use a tan inverse. So that lets me know right now okay, so that lets me know right now that I'm going to use theta is the tan inverse of u over a, because they look alike. So whenever I see a squared plus u squared, I'm using a tan inverse. So that says that the tangent of theta is u over a, or u is a times the tangent of theta. Okay, so I got that far. I need du. It's a secant squared theta d theta. And I also know from my partner functions that the partner of tangent is secant. So therefore, if I put this, u over a is the tangent of theta. So that makes this side the square root of a squared plus u squared. So let's solve for the secant because it's the partner function. The secant of theta turns out to be the square root of a squared plus u squared over a. So now I can solve for that thing. The square root of a squared plus u squared is a times the secant of theta. So now I can substitute everything in that I need. I only need the square root of a squared plus u squared. Oh God, this is the hard one. I only need a squared plus u squared, and I need square root of that, and I need du. So this integral turns out to be 1/2 the integral. The square root of a squared plus u squared is a secant theta, and du is a secant squared theta d theta. So this is a squared over 2 times the secant, the integral of the secant cubed of theta d theta. Now we already know this case we have to do by parts. Okay. So just as a review, nope, that's not what I want. Yeah. Now, we did this problem by parts already. I'm not going to do it again. It's in my integration. No, it's in my trig integrals here. It's here. So we did the integral of secant cubed. We did it by parts. There it is. We already did it. Yay. So this is going to equal a squared over 2. Well, we know a is 1, right? So that's just 1/2. Actually, let's leave the a in for a minute till we get to the end. A squared over 2, and the integral of secant cubed is going to be 1/2 times the secant of theta, tangent theta, minus the natural log of the absolute value of the secant of theta plus the tangent of theta plus a constant, because we've already calculated it. How nice of us to have done that. Okay. So now I have everything in theta. So now remember, we went from x to u to theta. So now we got to go from theta back to u back to x. So let's go back up to our triangle. Oh, there's our triangle. Okay, so in my triangle, I have, this is a squared over 4. The secant of theta, well, we already know what the secant of theta is. It's the square root of a squared plus u squared all over a. And then the tangent of theta is u over a minus the log of the absolute value, the secant of theta, a squared plus u squared over a, plus the tangent of theta, u over a, plus a constant. So now I've gotten from theta to u. So now I've got to go from u. So now I have to put back in u and a. So we said u was 4x squared and a was 1. So my answer, a is 1, so I get 1 over 4. A is 1, so I don't have to worry about dividing by that anymore. So a is 1. So I'm going to get the square root of 1 plus u squared is 4x squared. Oh, this is times u. Let me put the u in front. U is 2x. Okay, so that's u times the square root of a squared plus u squared minus the natural log of the absolute value of 1 plus 4u squared, I'm sorry, 4x squared plus u, which is 2x plus a constant. Okay. All right. I think some of you are still struggling with a couple of things. That is, U substitution is still giving some people some grief. Okay. Then I also think trig integrals is giving some people some grief. So let's try to see what we can do about that. still can't get this right. I don't know what's wrong with me. Okay. So the first thing happens is both M is odd. So that's the power of the sign is odd. So then you're going to take and split this off as the integral of the sine of m minus 1 x cosine of nx sine of x dx. So m is odd. Pull off one sign and then trade these off and then use sine squared is equal to cosine squared x minus 1. Okay. N is odd. So you're going to take the integral, you're going to leave the sign, you're going to pull off a cosine. And then everywhere you have a cosine, you're going to use the cosine squared of x. This is hideously wrong. That is 1 minus the cosine squared. You're going to be 1 minus the sine squared. Okay. M and N are even. Then you will use the sine squared of x you will use the sine squared of x is 1/2 times 1 minus the cosine of 2x. And you will use the cosine squared of x is 1/2 times 1 plus the cosine of 2x. Okay, does that make sense for the first that first type of problem? Does everybody understand what happens here?
Yes.
I do.
Anybody else have questions? Not sure what to do?
Can you scroll back up to that first box?
Yes, I can.
Okay.
So if the power of the sign is odd, pull off a sign and let that be your derivative. If the power of the cosine is odd, pull off a cosine. Let that be derivative. If they're both even, you can't pull one off. Don't. You have to do the double angle formula. You have to do this. You have to figure out how to do that. You have to substitute them both in and then integrate those things. Okay. That's it for those. It seems like we did a whole lot of cases, but that's it. That was the only cases. That was it. Okay. Okay, we're getting ready to run out of time, so I'm gonna have to, we'll have to work on this again. But the first case is that M is odd. Okay, we'll pick up here on Monday. Guys, try to finish the table. Try to finish this table. Okay. You got an exam next week.